Wobbly space dog. And it's this little plastic dog toy, and I got it in a cereal box. That's what makes it so special to me. And this is a physics toy that came in a cereal box. I love it. Okay? And I'm going to show you how this little wobbly space dog works. And I'm also going to show you just a regular old balloon. Nothing special about that. But I'm going to demonstrate these two things. And the reason I showed them on the projector first is because you might not, in the video, might not be able to see them very clearly once I get started. So the first one, we're just going to spin the camera right around here. Probably works.
Yeah.
The first one is I'm just going to take the balloon, blow it up, and let it go. So it's unpredictable, by the way. It's very hard to know where the balloon's going to go. But what did you see? The balloon took off, looped around my head, and crashed. How is that an example of Newton's third law? How is it an example of Newton's second law? Thoughts? Start with the second law. What is the second law? F equals ma. Yep. So how does it show net force equaling mass times acceleration?
It's going forward.
Going forward, so there must be a force which is causing an acceleration. All right, there's some sort of force which is causing an acceleration. Fine, so it's Newton's second. How's it Newton's third?
Well, the air is exerting.
Before it even hits the ground. Let's talk before it hits the ground.
The air on the outside. Well, the air
There's
on the
air
inside.
coming out of the balloon.
Yes.
What's it pushing on?
Outside.
It's pushing on the air in the room. So you have air pushing on air. Equal and opposite force, which causes the net force to be a forward acceleration. Okay, see how it relates to both laws? Simple demonstration with balloon. Can you see this? Right here?
Kind of.
Kind of?
Kind of.
What if we spin it a little bit further and slide it down?
We're going to do that.
Check it out from the other side, see if it's going to work. So I have this wobbly space dog here, and the wobbly space dog has a string. Is it going to work if we get down here? Keep going lower.
Alright, that's not bad.
Yeah, we do that.
Right there?
Yeah.
Okay. You just have to be close enough that you can see. Wobbly space dog has a string with a little mass hanging from the end. So when I put the wobbly space dog here and let him go, he starts walking. Oh, not to fear. Ooh, he never falls. Let's try again. Poor wobbly space dog. He's getting old. Let's try again.
That's pretty cool.
Okay, wobbly space dog. You made me nervous there. You're like defying the laws of physics for a moment. Okay, so wobbly space dog will walk up to the edge of the table and then stop. It didn't the first time, but hey, that's the way things go. All right, so let's try it again. See if he works correctly. Wow, he's getting risky in his old age. Walking a little too close to the edge. Let's try it over here. There we go. Okay. All right. I don't know what it is. He doesn't like this one spot. He walks right off the edge every time. But so wobbly space dog is also a physics demonstration of both the laws. How is it the second law? Real quickly.
The force.
Force. What's providing the force?
Gravity.
Yeah, the mass is actually providing the force of gravity. So force of gravity is causing acceleration. He accelerates towards the edge of the table. And then, why does he stop?
Because the weight's balanced out.
Directly below his mass.
Okay, which is almost relates back to the center of mass demo we did a day or two ago, where we said we did the hammer hanging from the table, and if the center of mass was below or underneath the edge of the table, you can't go anywhere. That's kind of what's happening right now. So the mass is actually probably right there, and so that wobbly space dog walks straight up to the edge and he stops most of the time because of where the center of mass is. How is this Newton's third law, though?
Well,
Right now, it's Newton's third law.
The normal force and the gravitational force.
Yeah, right now there's a force of gravity pulling down, and there's a normal force supporting the dog upward. And since the forces are located center of mass underneath the edge of the table, the dog just stops at the edge. One more time, and then we'll call it quits for today. Wobbly space dog. Please don't fall. Oh, good job, Wobbly space dog. Physics.